throughout this entire lesson, we've been talking about factoring, right? Just coming up with the two binomial factors of maybe a trinomial or a binomial of degree 2, okay? Well, now we're actually solving the equation. So we're going to use that zero product property. Okay, so let's look at a couple examples that might be slightly different, okay, maybe a little bit more challenging. All right, well, the first example is negative 2x squared plus 12x minus 18 equals 0. Okay, well, the first thing I notice right here is that this negative 2 or the 18, none of those are perfect squares, right? So I notice all these numbers are even, so let's go ahead and I'm actually going to take out a negative 2. Okay, one rule that we haven't talked about yet is that if the leading coefficient is negative, we always want to factor out the negative. Okay, and what I'm going to do now is divide each of these terms here by negative 2, and I'm going to write down what's left over. Okay, so if I divide that by negative 2, I'll be left over with now x squared. This will be minus 6x, and this will be a positive 9. All right, so really at this point we should kind of see that well, this is a perfect square, this 9 is a perfect square, and so is this number out front. We notice that this middle number is negative, so this should actually fall into our special factoring patterns. Okay, if I want to rewrite this, eventually we might skip this step a little bit just to save some time. But if I want to rewrite this as you know, with the a's and the b's, or as our pattern, I could write this as this is the quantity of x being squared minus 2 times a times b, and then plus b squared. Okay, I could write this as well. This would be x, and this would be 3, and this would be written as 3 squared. Right, so I'm really just kind of proving that this actually falls into our pattern here. So I can write this as now negative 2 multiplied by, and this is going to be x minus 3, the quantity of x minus 3 squared, and that's going to be equal to 0. Okay. Well, what's a little bit confusing at this point is how do we solve this? And so to solve this, I'm actually just going to split this up as negative 2 multiplied by x minus 3 times x minus 3. Okay, and that equals 0. So how we actually solve this is we're going to set each of these little factors equal to 0. Okay, so I'm going to set x minus 3 equal to 0 and x minus 3 equal to 0. This negative 2 equals 0. If I look at this part, really, that just doesn't make any sense, so we just kind of skip it. So we'll set x minus 3 equal to 0. Again, this is the zero product property, and x minus 3 equal to 0. And when I solve this, I get x equals 3 and x equals 3. So we see in this particular problem, there's actually only one solution. It's 3. But I'm just going to say, I want you guys to write that there's a multiplicity of 2. Multiplicity of 2. Okay? And that's going to be important when we actually start graphing these things. Okay, now let's look at part B here. Okay, a little bit different on this one. We have x squared plus x plus 1/4. Now I know some of you guys might be going, oh my goodness, how on earth are we going to write 1/4 as a base that's being squared? Okay, so let's just skip that. What I'm going to do instead is I'm just going to multiply this entire equation by 4, so we actually get rid of that. So I'm going to multiply everything by 4 here, and I'll end up getting 4x squared plus 4x plus 1, and I'll set that equal to 0. Okay, so this is perfect now. I know that again this number is a perfect square, and so is this one. And so I should theoretically be able to write this as a perfect square trinomial. Okay, so I'll write this as the quantity of 2x being squared plus 2 times a times b. So this would be 2x and 1, and then plus b squared would look like this. Okay, and so I've kind of proved that it's going to fall into our pattern. So I should be able to write this as now 2x plus 1 squared equals 0. Okay, and I'll now write this as 2x plus 1 times 2x plus 1 is equal to 0, and I'll use the zero product property, right? So I'll set 2x plus 1 equal to 0. I'll do that twice. Okay, and I'll notice that I'll get only one answer, but it's the same answer. Right, so if I solve this particular equation, I'll subtract 1 from each side to get 2x equals negative 1, and I'll divide to get x equals negative 1/2. Okay, it'll be the exact same steps for this other one, right? X equals negative 1/2. So these are our answers. This is our only answer, x equals negative 1/2, but there is a multiplicity of 2. Okay, now this is just getting you ready for Algebra 2. There's a multiplicity of 2 because it was a repeated solution, okay, is what this means. Okay, and it's going to be important, again, for when we actually graph this. Okay, so we'll definitely go over more of these particular examples in class, talking about different multiplicities and more factoring examples and things like that.